Hello everyone, it's indeed inspiring to see you back again, and you are watching Understanding and Planning of Hadoop Clusters tutorial. This is part 5, and we are going to discuss today typical workflow in Hadoop. We have operations like load, read and access, and process. So three different types of operations are there. You can categorize them into two only. One is HDFS related, which is load and read, and another is MapReduce, that is processing related. Now let us try to start with the load operation. The basic load operation can be understood as follows. We have a client machine, we have name node from HDFS, and we have multiple data nodes from HDFS. I believe you remember that HDFS is made up of name node and multiple data nodes. So here we have multiple data nodes which will contribute their storage to create the whole set of HDFS. Now client basically has got data and client wants to store that data into HDFS. So client will make a request to the name node. This is step 1. After client making a request to the name node will check the FS image. So step 2 is name node is going to check the FS image. FS image is that file which contains information of all the data nodes and what sort of blocks are stored in those data nodes. So after getting that information, in the step 3, name node will send address of a data node to the client so that client can go and write the data. So step 4 is client will go to a particular data node and write the data inside the data node. So you can see that file.txt was there with client and it is now written in data node, this particular data node. After the data is written into data node is going to send an acknowledgement to the name node. This is step 5. So this is how a basic load operation takes place. Now there are two more concepts. One is replication factor, another is block size. So this file you can see I have written here 128 MB. So Hadoop follows a block size. The default block size as of now is 128 MB. And you can have a file of size 256 MB. So 256 MB file will be divided into two blocks. Similar way, there is another concept of replication factor. That means your one block will be stored multiple times. So by default, the replication factor is 3. So one block needs to store as 3 times in the HDFS. So let us see that part as well. Here we are seeing the replication factor first. So this file .txt is 128 MB. That means only one block will be created for this particular file. And step 1 is client is making request to the name node. Name node is checking the FS image, but this time name node is aware that I need to send 3 addresses to the client because total 3 copies of the same file, same block needs to be stored in the data node. So name node is sending as a step 3 data node addresses. And after that, step 4 is that client visits the data node and stores the data. Client had 3 addresses. Client will visit that data node which is nearest to the client. And after that, client will pass all the addresses to this data node so that this data node can make copies into other data nodes. So here you can think of a question which may be asked in the interview. Who will write the data into HDFS? So client will write the data into HDFS because in both the steps we have seen that client is writing the data to the data node. But who will create the replicas? Data nodes will create the replicas because data nodes can communicate with each other with lesser bandwidth and lesser time, while client is external entity. So if client wants to store the same data 3 times, it will consume more time as compared to data node copying the replicas. Now let us go ahead and understand the block size. So if we have replication factor of 3 and block size of 128 MB and assume that the file size is 256 MB, in this case, the file will be divided into 128 MB plus 128 MB, which is equal to 256 MB. So 2 blocks. Now, when client makes a request to the name node knows that there are 2 blocks. So name node will check the FS image as step 2. In step 3, name node is going to send 3 different data node addresses. Why 3? 3 for block 1 and 3 for block 2. So total 6 data node addresses would be there. Now, with these 6 data node addresses, client will go for block 1 and will write the data into one data node for block 1. And as we have discussed earlier, rest of the replicas will be created by this data node itself. Then client will go for the block 2 and will write the block 2 in the data node, and rest of the addresses will be sent to this data node, and this will take care of the replicas of the rest of the blocks. And once the data is written in the data node sends a heartbeat as well as a block report to the name node so that name node is aware that the data is successfully written, and further name node can update the FS image. So this is how the load operation works with replication factor as well as the block size. Further moving, we know that in Hadoop, hardware can fail sometime. So if a data node fails, then what happens? This is what we are going to see now. Before that, let me explain you one thing, there is a heartbeat mechanism. Heartbeat mechanism is that, for example, if my heart is beating, it tells that I'm alive. Similar way, these data nodes, they keep on sending heartbeats to the name node. So sending heartbeats to the name node means that this means that the name node is getting to know that data node is alive. So if data node is alive, then name node can utilize that data node for storage purpose, as well as whenever client requests for a read, then also name node sends the address of the data nodes to the client so that client can read the data. So in both of the cases, loading and reading, name node considers those data nodes which send heartbeat to the name node. Okay, now here you can see failure. The step number one is data node fails to send the heartbeat. So if data node fails to send the heartbeat, name node will not receive the heartbeat. Name node will also not receive the block report. So name node identifies that there is a failed data node. And now name node is concerned. Why name node is concerned? Because this particular data node has got this file.txt, one block of 128 MB. So name node thinks that I have a replication factor of 3, but now for file.txt, one replica is less. So name node immediately checks that where is the other data node where this file.txt is present. So Namenode instructs as a step 3, Namenode instructs that data node that you create one more copy of file.txt so that we have 3 replicas. So this data node is creating one more replica in another data node. So this is how Namenode is able to maintain 3 replicas all the time. Okay, now you may have a question that let's say after some time, this particular data node is getting up and it is active. So we have this particular block of file ready. So in this case, now we have 4 replicas. In that case also, what Namenode does, Namenode basically tries to identify that which data node is having more load. So whichsoever data node is having more load, Namenode will instruct that data node to delete the replica so that when we have 4 replicas, Namenode is making one replica to be deleted and keeping the replication factor 3 as it is. If there are less replicas, Namenode asks one of the data node to create additional replica so that again 3 replicas are present. So this is how Namenode maintains the failure of the data node also, and there is no problem in accessing the data to the client also. Now moving further, now we have a concept of name node and secondary name node. Here you can see that this particular first box is representing name node, second box is representing the secondary name node. Secondary name node is a helper to the name node. Secondary name node is not a backup to the name node. This is very important point. Okay, I always give example of Gajni. Gajni tend to forget everything. Okay, and therefore he had to write everything on his body. Similar way, name node basically gets the heartbeat and a block report from the data nodes. But name node is not able to update those reports, and the reason is because name node is busy in serving the client request. Client request could be load the data and read the data. So name node is completely busy in that. If you want name node to update the FS image, then what name node needs to do? Name node needs to shut down and restart. Okay, so once you start the name node, at that time, name node reads all the edits and then it updates all the edits into the FS image. This is what name node does. Okay, and during this time, what happens? The client requests are on hold and pending. Okay, so this cannot happen every day or every hour. This is a difficult thing because these edits are keep on coming. Edits are nothing but the block reports which name node is receiving from the data nodes. So what happens here? Secondary name node becomes a helper. Secondary name node tells that let me copy FS image and edits. So SNN collects FS image and edits from the name node and it copies it into its own machine. And then it basically updates the FS image the way name node does. So name node need not to shut down now. Name node is busy in serving the client request and SNN, the secondary name node, has updated the FS image. After the FS image is updated, secondary name node sends this FS image to the name node back again. Okay, this is the step number 3. So once FS image is here with the name node uploads this FS image into the memory and deletes the old FS image from the memory. What happens like this? So here basically name node gets the updated image. Name node need not to shut down and name node is keep on serving the client and name node just did one operation of deleting the previous FS image and uploading a new one. This is what name node did. Okay, and after that, by that time, lot of new edits, lot of new files have been generated. So what happens here? So here basically these edits are again copied by the secondary name node and it again follows the step 1, step 2, step 3 and step 4. This is on an average every hour this activity happens. This is how name node is able to keep the FS image updated and keep on healthy way serving the clients. Okay, so this is the relation between secondary name node and name node. Now let us move ahead. There is a concept of racks. So racks are physical racks, like we have racks where we keep our books or we keep our clothes. Similar way, these are CPUs which are kept into one rack. One rack means one switch which has connected all these CPUs, another switch which has connected all these CPUs, another switch which has connected all these CPUs. Okay, so when we have a rack, then in that case, what Namenode does, Namenode will basically request the client. Okay, will serve the request to the client. So client basically makes a request to the name node we have studied. So while responding to the client, what name node will do, name node will give address of first rack, okay, to store the data, and the second and third address it will give from the other rack. Now you will think why name node does this way? Because we know that hardware may fail. So let's say if one data node goes off, then we have seen that how that can be resolved by the name node. But let's say in worst and the worst case, if the whole switch gets corrupted or it got shut down, which is a very rare case, but let's say if happens, so if the whole rack is not available, then also at least we have another rack where one or two copies of the block are present. You can see that how smartly this has been designed. So client will store one block at one particular data node in one rack, and another block will be stored in another rack, okay, and the third block also stored in the third rack, the same rack, okay, another rack only. You can see the diagram. This is how the rack awareness is there with the name node or HDFS, and that is how they store the data. So that's it for the day. Thanks for watching. Do like, share, and subscribe. Wait for the next video.